In this section, we're going to learn about algorithms, which is part of the foundation of computer science. Algorithms are important because they allow computer programmers to tell computers what actions to take in the process of accomplishing a goal. We will explore a simple example of an algorithm. Then we will look at how to prove the correctness of an algorithm. Finally, we will learn how to calculate the efficiency of algorithms. To begin, let's look at a theorem from number theory. Let's look at the quotient remainder theorem from number theory. According to this theorem, if n is an integer and d is a positive integer, then there are integers q and r such that n equals dq plus r, where r is bigger than or equal to 0 and less than d. Q is called the quotient and r is called the remainder. The quotient and remainder are unique. What this theorem says is that we can divide n by d, and n can be written as a multiple of d plus some remainder. Okay, q is the number of times that d goes into n, and r is the remaining number after d has gone into n as many times as possible. For example, let n be 51 and d be 4. Then 4 goes into 51 like this. So 4 goes into 5 once. Drop the 1. Okay, now 4 goes into 11 2 times. Okay, so 4 goes into 51 12 times, and the remainder is 3. (51) equals 4 times 12 plus 3. Here, q equals 12, and r is 3. Let's do another example. Let n be 25 and d be 7. So take 7 into 25. Okay, so 7 goes in 3 times. And I get a remainder of 4. So q is 3 and r is 4. We can also find q and r by subtracting d from n many times until we can't subtract anymore without running into negative numbers. So take 25 minus 7, that's 18. Okay, subtract another 7. That's 18 minus 7, and that's 11. Okay, subtract another 7. That's 11 minus 7, which is 4. Okay, we can't subtract anymore since 4 minus 7 is negative 3, and that's a negative number. So we stop. The number of times that we subtracted 7 is q. So q is 3. The remaining number is r, so r is 4. Okay, in general, if n and d are positive integers and n is greater than or equal to d, then we can subtract d from n multiple times until we reach a number that is greater than or equal to 0 and less than d. Now, if n is less than d, then n equals 0 times d plus n. So in this case, q would be 0 and r would be n. So here's the procedure. Start with n. If n is less than d, then stop. N equals 0 times d plus n. So q would be 0 and r would be n. Okay, if n is greater than or equal to d, subtract d from n, so we get n minus d. And let r be n minus d. If r is greater than or equal to 0 and less than d, then stop. We would have n equals 1 times d plus n minus d. So q would be 1 and r would be n minus d. If r is greater than or equal to d, subtract d from r. So r minus d would be n minus d, which is n minus 2d. Okay, and let r be n minus 2d. If r is greater than or equal to 0 and less than d, then stop. N would be 2d plus n minus 2d. So q would be 2 and r would be n minus 2d. Okay, and we keep doing this. We keep repeating this process until we reach a remainder r, n minus qd, where r is greater than or equal to 0 and less than d. Once we reach this stage, the quotient will be q, and the remainder will be n minus qd. Note that q will be the number of iterations of this process before we stop.